All right, let's talk about irrigation. Irrigation. How do we water those crops? So, we use our fresh water in a lot of different ways as peoples. You need to realize on this graph, we, like in our domestic usages, don't use that much water. They're always telling us, cut down your water use, cut down your water use. You're causing to the drought. You're contributing to drought. But look, are we? I mean, yeah, we can do our part, but look where the major use of water is. Fresh water, almost all of it goes to irrigation. Watering the crops, watering our grasses for soccer fields, at baseball fields, at football fields, at parks, and things like that. So the big, I want to say, consumer of fresh water is irrigation purposes. Industry uses a lot just for manufacturing and the process of making goods and services, but the big use of our fresh water really is in irrigation. So things like going to artificial turf are real. Just a little fun fact before we get going. Our soccer field at Anaheim High School, I pulled the bills. I asked them to send me the bills, and it is unreal of how much it goes into watering our grasses. It is 1 million gallons of water per month. Oh my gosh, it's nuts. So if we got an artificial surface, that would be a lot better. Okay, but this is more focused towards our crops and our food because this is our agricultural unit. So we'll come back to this later on. All right, so when we irrigate and when we choose how we irrigate, because there's different ways to do that, makes a big impact on the environment. So one of the ways that's been most common is this process called waterlogging. And basically you just fill the soil up with water and let it soak in. Now, there are places where waterlogging is natural, like a swamp or a marsh. Those are ecosystems that are literally underwater. We are not talking about that today. We're talking about ways we water our crops. Rice paddies need to be waterlogged to grow the rice. They actually have to be underwater to do so. When we water, and we'll have a picture of this pretty soon, but we usually plant our crops in rows, and then we insert the water between the rows for the crops to grow. So that's what I'm talking about right now for waterlogging. We saturate or cover the soil with water, and we let that water soak into the dirt and water the plants that way. So here's some consequences of choosing waterlogging. Number one, it uses a lot of water, but it also stops the plants from breathing. If they're drowning in this water, plants need to breathe oxygen too. I know we don't think about that a lot because we always think, oh, they make oxygen because they do photosynthesis, but plants actually do both. They breathe in, they expire just like we do. So if they can't breathe, they're going to die. So there is such a thing as giving your plant too much water, and there is such a thing as drowning your plants. When you cover them in water, again, that gives them an anaerobic situation. There's no oxygen. That's what anaerobic means. No missing. I can't even spell. That says missing, believe me. There's a lack of aeration, so the air isn't cycling through with the oxygen, and the plants literally cannot breathe. When the soil is covered with water, plants will release more nitrogen dioxide, which is a greenhouse gas, which will warm up our planet. Covering soil with water also decreases the pH, which means it becomes more acidic. And we've talked a lot about soil acidity and what happens. Another thing that happens if the water is covering the soil, it lowers the temperature of the soil, and that might make the microbes in the soil less active and they're not doing their jobs in cycling nutrients as well. And the last thing it can do is bring salts to the surface, and that it can be very toxic to plants. And we call that salinization. And salinization is literally just the sal, Spanish, in the groundwater, and it stays behind after all this water is evaporated. So the water, the H2O, will evaporate up into the atmosphere, and that's not such a bad thing. But what is left behind are the minerals or salts in the soil. So remember, salt in chemistry is not just like sodium chloride. That's a whole family of chemicals. And that can be aluminum, it can be barium, it can be a whole bunch of different things. Lithium, it can be sodium, but it's just usually it's a positive cation connected with a negative anion, and that's what we call a salt. So it's not just like, oh, table salt's on the ground. That's not what we're talking about. But what salts do, these salts, is they interfere with the nitrogen uptake in plants. And we've talked about aluminum doing that before. Aluminum's a +3 and it'll block the roots, but all these other minerals that are salts also can do that. And if they're left behind in the soil, they prevent that nitrogen, which is the food nutrient the plant really wants, and it gets blocked by something else. And so then the plant can die. This method of irrigation causes us to lose a lot of crops each year. Look how much, $27 billion worldwide of our crops are lost because of salinization. Don't do it. All right, another thing that can happen by overwatering is we deplete our aquifer. So we usually get our irrigation waters out of an aquifer or out of a river or some sort of body of water. In Los Angeles, we get it from a place called Mono Lake out by Mammoth. And depending on the watershed, it's watershed dependent. So if there's no water raining down into the mountains and shedding into this lake, we get a drought. And that's why we always have a drought, because we don't get a lot. Okay, but like where we are in Anaheim, we've got that really cool aquifer I keep telling you about. Oh, sorry. Why am I putting it out in the ocean? That was dumb. It's over here. Aquifer. This is the ocean, Miceli, duh. There's the ocean. So what happens here is we get this rainfall and we have fresh water in our aquifer. We have this barrier right here, and this is where salt water is versus fresh water. And there's actually like a little bit of physics going on here. There's pressure from all this soil and fresh water, and there's also pressure this way from the ocean. And so we have this equalized pressure, and it's kind of balanced out. So as long as they're balanced, everything's fine. If we start taking out too much aquifer water, fresh water over here, this is going to lessen the pressure on this side. We're going to have a smaller arrow, and we're going to have a bigger pressure on this side. And guess what? This ocean water is going to come in to our fresh water, and we call that saltwater intrusion. And we do not want that. We do not want this saltwater intrusion, because then it will contaminate our fresh groundwater in our aquifer with salt water. Who wants to drink salt water? No one. So we don't want that to happen. So we have to very carefully measure and keep it a constant rate. We cannot take out fresh water more than the rate that it gets replaced or replenished. So our replacement rate needs to equal or be greater than or equal to our extraction rate. If we don't do that, we'll get this saltwater intrusion, and then we won't have any fresh water because it will all be salt water. And you will die if you drink salt water. Okay, super famous example for this is the Ogallala Aquifer. When I first started teaching apes, a lot of people thought that was in Africa because it sounded like some African name, Ogallala, but it's not. It is in the US. It is in right here. The center is a huge, huge aquifer. It's basically the aquifer that does the whole breadbasket. Parts of Texas, Kansas, Do your states, part of Colorado, whatever's above Kansas. I don't remember my states anymore, you guys. I'm bad. Sorry. Mr. Rodriguez to be mad. All right. Anyhow, it is the primary source right here, important part, for water and irrigation. And we are depleting it like crazy. So watch this video about it. And then let me talk briefly about the different ways we can irrigate. So we just talked about this flood irrigation or waterlogging. We don't want to do that. So another one is called surge irrigation or furrow. It has two names. Then we have seen this one a lot. That's the one we usually see, the sprinklers. And then there's this other one called drip. So I'm going to really briefly talk about these, but I want you to kind of look them up and study them on your own also. So the furrow is we've got these rows of crops. We run the water down and it gets soaked in. It's a little less than flood irrigation because we're not totally covering the plant. We're just covering these low parts right here. So the plant's actually up on top of these little peaks. Sprinklers, it's a spray. And you can probably imagine, you've probably seen this at the sprinkler system at your own house. There's a lot of evaporation involved. And there's a lot of water that doesn't even go on the plant. It goes on the dirt. So there's a lot of waste of water because it doesn't actually get to the plant that you're trying to water. And then there's drip. And so drip is a little tube that goes straight to the plant and delivers it at the base of the plant. So there's no spray, there's no over evaporation. It's just what it needs, when it needs it, right where it needs it. And so this is obviously the environmentalists' approved method, except, it's expensive. There's a lot of labor involved to make it happen, blah, blah, blah. I want you to kind of study about this. Okay, so here's your job. Make this chart, copy this chart, and fill out all of these options. So do a little pro-con for it. So what is it? How does it work? And I did flood for you. Is it relatively costly? High, medium, low? Just give me high, medium, low. High, medium, or low cost. How efficient is it? You will actually find percentage efficiencies for it. And what happens? How efficient is it? What happens with evaporation? What happens with runoff? So tell me what happens there. And then the pros and the cons environmentally. So flood irrigation, there's not a lot of pros, so I didn't put any, but some of these have pros and cons. So as you do your little research, do that. And then we'll check it when I see you next time. Good luck.